Hello friends, do you know installing a VFD drive above sea level, I mean on hilly area or at some altitude above sea level, reduces the actual current rating of the VFD than design ratings. Or when the ambient temperature surrounding the VFD goes up, it also reduces the rating of the VFD. Isn't it strange? So what happens when VFD is taken to altitude or the surrounding temperature goes up? For these reasons only, such applications require a VFD larger than the normal, even as per motor design VFD. Now this process is called VFD derating. That means you intentionally using larger VFD than the required. Because you know altitude or sounding temperature, higher sounding temperature will reduce its current rating and want the VFD to operate normally and handle load safely without tripping the motor. Got it? Technically speaking, VFD derating is required when the VFD is operated outside the operating range specified by the manufacturer. Here operating range stands for when it is operated at higher altitude than the prescribed altitude or prescribed ambient temperature in the VFD data sheet. Basically we can say this is a selection practice in which the VFD is deliberately chosen or selected higher than the normal required for the motor designed to get a safe and reliable operation without tripping. But why would you choose higher VFD than the required one? Don't you think it will add some additional cost on your project? There are several factors due to which a VFD derates and operated at a reduced current rating. An instrumentation engineer must know all these reasons and derating concept of the VFD while designing a project or making selection for the VFD. Many times VFD derating is misunderstood. I mean, if the motor and the VFD both are operated at the same relative environment, then there is no need to derate the VFD. Let's understand this phenomena. Suppose a 10 HP motor and corresponding VFD both working well at sea level. If say motor and VFD are taken to 10,000 feet above sea level, then both of them get derated together on its full current rating. So there is no need to change the motor and VFD. Both will continue to work at a slightly reduced capacity because the environment of the both has changed relatively. Clear? That's why manufacturers specify the VFD at an altitude of 3300 feet and 40 degrees Celsius ambient temperature. That means if the VFD is operated at within 33 feet above the sea level and the ambient temperature within 40 degrees Celsius, then the VFD does not derate its current capacity. So you are safe till 3300 feet and 40 degrees Celsius temperature. VFD will shed and derate its current capacity by 3% if you go further 1000 feet above 3300 feet and derate by 1% per degree Celsius above 40 degrees Celsius. Let's move ahead. VFD derating becomes an issue when you setting up a plant above 3300 feet and when the ambient temperature is above 40 degrees Celsius. But you specify the current rating of VFD as per motor load requirement at the time of procurement. For example, you need to specify VFD for suppose 200 HP motor at an altitude of 6000 feet. So for 200 HP motor, you need 230 ampere as an current output of the VFD. But you observe from its altitude current data sheet chart, a 230 ampere VFD not delivering 230 ampere at an altitude of 6000 feet. So you select a higher VFD and derate to make it capable to deliver 230 ampere at an altitude of 6,000 feet. So this VFD can fulfill the demand of motor in extreme load condition. Got it? Let's look out at the reason why VFD actually need to be derated. First one is altitude effect. What happens when a VFD is taken to above sea level? I mean when installed in hilly areas or some location that above than sea level. Atmospheric air pressure is found to be less in hilly areas than the sea level, due to which the density of air reduces, which means the air becomes thin. This thin air, when blown over IGBT heatsink, does not find it capable to transfer the generated heat out of the VFD. That means the air cooling efficiency of VFD gets reduced and it rises the temperature of heatsink and hence the VFD. Now this factor is mentioned in VFD data sheet. But as general rule of thumb, VFD current rating is derated by 1% per degree Celsius. In some of the VFDs, current rating reduces by a factor of 2%. For this reason, VFD manufacturer designs VFD at 3300 feet. If installation is above 33 feet 100, then a general rule of thumb is VFD current rating is reduced by 3% at every 1000 feet above 3300 feet. So this thing should be in mind while designing project or selecting a VFD. If you refer to the VFD user manual, you will find the altitude current chart for its derating factor. Okay, let's consider the situation. VFD is installed below 33 feet 100 location. But if the ambient temperature surrounding the VFD goes up, VFD2 derates by 1% per degree Celsius as discussed earlier. That's why VFD are always installed in air-conditioned panel room to keep the temperature below 40 degrees Celsius so that we can encash its true full capacity. But if the VFD is installed at some remote location where air conditioning is not possible, then the ambient temperature rises up to 45 to 46 degrees in summer season. Then derating of VFD is the only solution. Or you will be getting calls from the control room for this frequent tripping, or it may fail on hardware part permanently. So calculate its derating according to rise in temperature in peak summer season. Due to high switching frequency of IGBTs, the temperature of VFD also rises. I think you must be aware of switching frequency of thyristor IGBTs is fixed from 2 to 5 kHz. If this frequency is high, then the more heat is inevitable across the thyristor. The problem can be solved to some extent by reducing the thyristor switching frequency. However, the manufacturer decides the range of switching frequency, what it should be, how to dissipate generated heat, what are the characteristics of motor, load condition, switching losses. This is totally different chapter. We will discuss it in another video. The next factor is the VFD duty cycle. Is the load on the VFD continuous or intermittent? It depends on the application of VFD. If it is continuous load, the increase in temperature causes the VFD to derate when compared to intermittent duty cycles. Operating a VFD near maximum rated capacity for extended period of time may also result in overheating. The problem of overheating can be solved by derating the VFD here also. Poor quality such as voltage spikes or harmonics in the power supply can affect VFD performance. Here this can be handled by derating the VFD. You must have observed in all the factors we have discussed so far, the temperature of VFD was rising, be it higher altitude, ambient temperature, IGBT, switching frequency, or due to continuous duty cycle. So why this rise in temperature causes VFD to derate? What happened inside a VFD? We have studied any rise in semiconductor temperature. The characteristic of electronic components like IGBT, capacitor and other circuit components change or shift to other level or may cause breakdown of the electronic components. You would have observed many times VFD getting tripped on overcurrent fault with no obvious reason, even it is running less than the prescribed load. This overcurrent signifies rise in temperature and is derating VFD to trip below normal load. It may be due to altitude, sounding ambient temperature, switching frequency or continuous duty cycle. Reason will be temperature only. Due to derating, the temperature of the component does not go beyond a limit and may cause the component to fail permanently. Rise in temperature causes thermal stress on the component, due to which its material gets degraded and solder joints may get loose. Now let's see, how is this derating effect tackled? The only solution to ensure the VFD does not trip at an altitude less than 3300 feet is to keep the ambient temperature of the VFD under control with the effective air conditioning and ventilation. Also keep the additional capacity margin on the air conditioning when one of the unit fails to maintain the ambient temperature below 40 degrees centigrade. The temperature of panel room AC must be monitored in the control room to ensure the AC remains in operation all the time. If the ambient temperature is not in control at remote location, simply derate the VFD. There is no solution. Voltage spikes and the harmonic can be handled by installing a reactors. It will reduce the problem of VFD overrating. Also protect the motor with the thermal overload relay to prevent motor overheating due to excessive load. This will avoid the need to derate the VFD. So friends, how about this video? Post your query, doubts in comment section. There will be new video soon on this channel. Meanwhile, you keep watching, learning and sharing with your friends. Bye bye. Thank you.